Good morning, students. In the last class, we have discussed about acid-base theories. In acid-base theories, there are three theories. One is Arrhenius theory. The second one is Lowry-Bronsted theory. And the third one is Lewis theory. According to these theories, according to Arrhenius theory, if we take, according to Arrhenius theory, so acid means if the substance donate proton or H plus ion in aqueous solution is called acid. If the substance donate hydroxide ion in aqueous solution, then it is called base. And according to Lowry-Bronsted theory, here acid means the substance should be donor of H plus donor, and if it is H plus H plus acceptor, then it is base. This is acceptor of the proton according to Lowry-Bronsted theory. And the third one, then the third theory, Lewis theory. According to Lewis theory, acid means it should, if it is acid, it should accept lone pair of electrons. And if it is base should donate lone pair of electrons. So we have discussed what is acid and what is base according to these theories. They are Arrhenius theory, Lowry-Bronsted theory, and Lewis theory. In this class, we are going to learn about titration. What is titration? And what are the terms used in titration? That is terms in titration. And we are going to learn about types of titrations. So these are the things we are going to learn in this class. First, we shall take the titration. What is titration? Titration means it is a quantitative and also the volumetric technique to determine the unknown concentration of a solution by the known concentration of a solution in the presence of indicator is called titration. So we know what is titration now. The titration means it is the quantitative and volumetric technique. So in this titration, we are going to determine the unknown concentration. It is used to determine unknown concentration of a solution by using known concentration of solution by using and by use of indicator is called titration. In titration, we use some of the terms. We'll see the terms one by one. now. So there are different terms we are using in titration. So they are called analyte or titrant, and then titrant, then endpoint or equivalence point, standard solution, and then we use the term primary standard, secondary standard, and buffer solution, and then we use the term indicator. So these are the some terms we use in titration analysis. We know what is titration analysis. It may be the quantitative or the volumetric technique which is used to determine the unknown concentration of the solution from the known concentration of the solution using indicator. Now let us discuss these terms used in titration. So what are these terms? What is analyte? What is titrant? Endpoint, secondary solution, standard solution, primary standard, secondary standard, buffer solution, and indicators. What is titrant? So titrant or analyte? The substance to be analyzed or to be determined is called analyte or titrant. In the titration, if you are going to estimate the particular substance present in the solution, that is called analyte or titrant, which means substance to be analyzed or to be determined in solution is called analyte or titrant. Then what is titrant? Titrant means it is titrant means it is a reagent of known concentration. It is a reagent of known concentration. Here, the titration, as it is a solution of known strength of concentration used in the titration, is called titrant. This the substance which is added to analyte, which means this titrant is added to the analyte. Already we saw in a titration is called titrant. By using this titrant only, we are going to find the concentration of an analyte. So the titrant, which means the solution of known strength of concentration used in the titration, is called titrant. Say for example, if you want to estimate the concentration of NaOH using HCl, here there's a known concentration is HCl, so it is titrant. Here the unknown concentration, we are going to estimate the concentration of NaOH. So here this is called titrant or analyte. This is analyte and HCl is titrant in this estimation. The next term is endpoint or equivalence point. It is a point at which the reaction between two solutions is just complete. It is generally represented by change in color or pH or change in conductivity. By using the change in color, change in pH, change in conductivity, we can find the endpoint of the in titration. Therefore, endpoint or equivalent points means the point at which the reaction between two solutions is just complete. Between two solutions is just complete. That point is called endpoint. Here we know that this endpoint is determined by use of change in color, change in color, or change in pH, or change in conductivity, and etc. So by use of change in color, change in pH, change in conductivity, we can determine the endpoint of the titration. So therefore, the endpoint shows, this equivalence point shows the endpoint of the titration. The next term is standard solution. What is standard solution? The standard solution means a solution of known concentration is called standard solution. It is a solution of known concentration is called standard solution. The concentration of this solution is known, then it is called standard solution. And then we have primary standard. Primary standard. What is primary standard substance? The substance as a primary standard solution, it is a solution of which can be prepared directly by dissolving its definite weight in definite volume of solvent is called the primary standard substance. For example, crystalline oxalic acid, anhydrous, sodium carbonate, more salt, etc. So these are all used as primary standard because these substances are prepared directly by dissolving its definite weight in definite volume of solvent. These substances dissolving in definite weight in definite volume of the solvent. Solvent, most probably we are using water, and the substance used as a primary standard should fulfill some of the conditions. The substance which occur in I mean uh, taken as a primary standard should fulfill these conditions. It should be in pure state, which means it should not be hygroscopic, which means it should not stick with the water, and non-deliquescent, so if the substance having these are the properties, then this is non-hydroscopic, then the substance is used as a primary standard. And then what is secondary standard substance or a secondary standard? This, if the substance to be secondary standard, their standard solutions cannot be prepared directly. If the substance used as a secondary standard, these solutions cannot be prepared directly like the solution prepared as the primary standard. For example, so your secondary standard means the solutions cannot be prepared directly. So this is called the secondary standard solution. For example, potassium permanganate, sodium hydroxide, and potassium hydroxide. These are all the substances used as secondary standard because these substances are in solution cannot be prepared directly, but we can standardize these. After preparing the solution, we can standardize these solutions, but we could not prepare the as a primary standard, so that it could not be prepared directly from the solid of these substances. Next we have the buffer solution. What is buffer solution? A solution that resists change in pH even when a strong acid or base is added or when diluted with water. The solution which is not changing the pH even the addition of these solutions in other reagent or the titrant is called the buffer solution. So if you had the buffer solution which could not change, it not change the pH of solution, even the addition of the buffer solution, that solution is called buffer solution. Therefore, the buffer solution means a solution that resists change in pH even the addition of strong acid or a base is called buffer solution. And then we have a indicator. What is indicator? Indicator may be any substance that gives a visible sign. So usually by color change of the presence or absence of a threshold concentration of chemical species, an acid or an alkaline in a solution. So the indicator is a substance that gives a visible sign, usually the color change. So the color change, from the color change we can determine, that is we can find that the presence or absence, the presence or absence concentration of chemical species. So we can find that the chemical species is present or absent. For that we can use the indicator. For example, methyl yellow. If you take methyl yellow, so this methyl yellow which imparts yellow color to an alkaline solution. So in alkaline solution, this methyl yellow gives yellow color. From that we can find out that the concentration of the species or the chemical species present in the solution. So far we learned what are the terms we are using in the titration analysis. Next we shall move into the types of titration. What are the types of titrations, or here, what are the types of titrations? There are many types of titrations when considering goals and procedures. However, the most common types of titration in quantitative chemical analysis, or redox titration and acid base titrations. So redox and acid base titrations are the most important titrations in quantitative chemical analysis. There are the four types of titrations. So one is acid base titration, then the next one is redox titration, and the third one complexometric metric titration, then the fourth one the precipitation titration. So these are the four types of titrations in the analysis: acid base titration, redox titration, complexometric titration, and precipitation titration. So these are the four types of titrations. First, what is acid-base titration? So acid-base titration, in this acid-base titration, an acid or a basic titrants reacts with an analyte, that is a base or an acid. In this type of titration, acid-base neutralization reaction takes place. For example, um, the titration between HCl versus NaOH. Here one is acid, another one is base. One is used as analyte, another one is the titrant. From the unknown concentration, from the known concentration, we can find the unknown concentration of the particular, whether it may be the acid or the base. We can. So here the reaction involves is the neutralization reaction, which means acid and base combines and gives the salt plus water. These acid base titrations are again we have the types. They are strong acid versus strong base, and then strong acid versus weak base. Next we have strong base versus weak acid, and the fourth one is weak acid versus weak base. So these are the further we can divide the acid base titrations into these categories: strong acid versus strong base, strong acid versus weak base, strong weak acid versus strong base, and weak acid versus weak bases. We shall discuss in detail later. Here and then the redox titration. What is redox titration? Redox titration, in this titration the titrant is used as acting as an oxidizing agent or a reducing agent. In this titration, oxidation reduction reaction takes place. Here oxidation reduction reaction takes place, which means a redox reaction is occur in this redox titrations. Here the redox, for example, redox titration between KMnO4 and potassium, that is potassium permanganate versus potassium dichromate. It is a redox titration. So if you are doing the KMnO4 titration between KMnO4 and K2CO2O7. So this titration is the redox titration because this titration involves both oxidation reaction as well as reduction reaction. This redox reactions we have further the types: permanganometry and iodometric and iodimetric. So these are the further types of redox titrations. Next we shall move into the complexometric titrations. What is complexometric titration? In complexometric titration, this complexometric titration involves metal ligand complexation reaction. This involves metal ligand complexation reaction. For example, if you are going to estimate the magnesium is estimated by using um, magnesium 2 plus EDTA. So EDTA, ethylene diamine tetraacetic acid, is used to estimate the magnesium or the calcium or nickel. We can estimate so volumetrically. So during the estimation, it forms complex between the metal and the EDTA, so that this is called complexometric titration. In complexometric titration, during the titration, there is a formation of metal ligand complexes, so that we say this is complexometric titration. In next one, we have the precipitation titration. What is precipitation titration? In this titration, the analyte and titrant, that most probably we are using analyte and titrant. These analyte and titrant react to form a precipitate. For example, the titration between AgNO3 and KCl. Here, these two reacts with and forms AgCl precipitate. So this is precipitate. During the titration, there is a formation of the precipitate, so that this type of titration is called precipitation titration. Now we learned clearly about what are the types of titrations. There are four types of titrations: acid-base titration, redox titration, complexometric titration, and precipitation titrations. And also we saw some of the examples. What are these titrations, and some of the examples are given. I hope you understood. In this class, we discussed about what is titration, what are the terms using in titration analysis, and what are the types of titrations we have discussed. There are four types of titrations: acid base, redox titration, complexometric titration, and precipitation titrations. In the next class, we shall discuss one by one what is acid base titration in detail, and redox titration, complexometric titration, and precipitation titration. Thank you.